Okay, so we were talking about the hoteling model, the Downs model, where we have single peak preferences, and we have a median voter, and people are competing for the median voter. And we had a story there where you won if you got 51% of the vote, right? And we saw if you can get 51% of the vote, then we looked at what policies the two parties were going to advocate. And we found that they would both go to the middle, that by going towards the middle, going towards the median voter, you could capture more of the voter. If you were outside of the fifth, if you were away from the median voter, the other guy could go just beside you, take all those votes, get the median voter, and win for sure. So everyone goes to the middle, everyone advocates exactly the same policy, and that's it. And that seems to capture something. Particularly, it seems to capture something about the US, where they got 300 million people, and it comes down to 10,000 votes, right? So they really do seem to be going towards some kind of, it might not be middle of the road policies, but it seems to capture half of the voters on one side, half the voters on the other side, for whatever reason. Okay. Now, if we wanted to think, well, that's all well and good. It's not exactly the original Downs model, and it's not exactly our hoteling model. We're going to change it slightly to be that. And if you think about like the US is a bit special. It's special in loads of ways, but it's special in particular because they have this first past the post system, right? If you get 51% of the vote, you win the whole thing. Whereas the whole rest of the world, more or less, has some variation on the parliamentary system, and there a party always wants more votes, right? It's better to have 60% of the vote than it is to have 51% of the vote. And even if you're losing, even if you're getting 40% of the vote, that's better than getting 30% of the vote. They have some variation of a proportional system where you just want more votes. Obviously, more is better, but you would like to, everyone to vote for you, but even if you're getting 20%, you would like to raise that up to 25%. And that gives you real power by doing that. In a parliamentary system. So we're going to look at that, where you want to increase the amount of vote that you've got, even if you're losing, or even if you're winning. Right? So it's not just getting the 50%, but actually getting the thing. Okay. And this is having trouble with size of fonts, clearly. We're going to do it with two parties. And we're going to do it the actual model. And this is more or less, the point of this is to capture a little bit of what's going on every place except the US, right? All right. So what are our assumptions? We are going to assume that we have a continuum of voters. So instead of having 3 voters or 5 voters, we have an infinite number of voters. And those voters are going to be distributed continuously on the policy space. So there's going to be there's going to be no lumps. There's going to be nothing where everybody is doing 0.75. Right? They're going to have some distribution. There's going to be some voters at all locations, so there's full support. So every single possible policy has somebody who thinks that that's their ideal policy. We're going to have 2 political parties, and they're concerned with maximizing the number of votes they get. And of course, I forgot to say here, but we have the single peak preferences that we know and love. Okay. Now, if we think about the continuum of voters, and we're not really going to use this too much here, but we're going to use it later, so let me introduce it. So we got our usual policy space, 0 and 1. And before I was putting individual voters down there, right? I put their ideal policy. And we can think about this continuum of voters as being, we just keep taking more and more and more voters. Now, if we take 1 million voters, that's not quite the same as a continuum, but it's not that dissimilar either. So let me just sort of take voters one by one and put them on this policy line. Okay. So I'll do them with a little X, as I've been doing. Here's a voter, 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 here's a voter. And then I get another voter that has the same policy preference as this guy. I'm just going to stack him on top. Okay. And then here's a voter, here's a voter, here's a voter, another one like that, here's a voter, here's a voter, here's a voter. And you can see that what I start to get is a histogram of the chances of having each thing. So this is saying, for example, if we did millions of these like this, it's very little chance. There's very few voters with that very extremely high policy preference, right? And there seems to be quite a few voters in here. That's saying that this bit is just, there's a higher probability of getting a voter, more density of voters in this area than there is in that area. Okay? So one way we can represent this when we have an infinite number, instead of just making this histogram one by one by one, is we can say our distribution looks something like that, where the height gives the proportion of voters that have that particular policy preference. Okay, so before I was always drawing utility like this. I was drawing people's utility function here. Now I'm drawing the distribution of voters. Not very many voters that have extremely low, not very many voters who have extremely high, lots of voters that have kind of middle high, a fair number of voters that have middle low, not too much in here. Okay. People with me here? Now that's kind of arbitrary, and it's entirely arbitrary. Our assumptions are that this has full support, so every single possible policy, right, has some amount of voters that are there, and there's no lumps, so we can draw it as a continuous sort of thing. Okay? It might jump a bit, but it's not infinite number at any point. Now, we don't normally do weird things like this, but it's perfectly fine if we do. Normally, we'd sort of think one of two things. You might think, okay, our voters are somehow normally distributed on there, right? And so that would be very few people with extreme policy preferences and a whole lot of people in the middle. That would be a reasonable thing to think. You might think, we'll do the US just because it's fun. It's somehow skewed like this. That is, not very many left-wing people, a whole lot of right-wing kooks, and then very few extremely right-wing, right? You could think about it like that. Typically, in theory, what they'll do is they'll just have a uniform distribution. Where there's an equal chance of a person having every single possible policy preference. And this is just because it's mathematically convenient, right? So you'll see that a lot, but it's not super important. We don't really think that populations are like that, but it's a simple thing to work with, and we can play around with it analytically very easily. Okay? The important thing here is that there's a continuum of voters. There's voters at every single spot, lots and lots and lots of them. So no one individual guy is particularly special. He's one of 100 billion people there, right? And there's no point that's not covered. So there's somebody who has every single policy preference. Okay? People understand what I'm doing with these graphs, with these distributions? You kind of vaguely remember this sort of thing from statistics class. They showed this up, right? You know, random variable of the continuous sort, that kind of thing. That's what's going on here. Like each individual guy's policy preference is a continuous random variable drawn from some distribution with full support. And I'm just kind of graphing that. Now, we're not going to use these graphs right away, but we're going to come back to them later. So it's kind of nice to introduce them now when we first introduce the assumption. All right. Now, somewhere in there is, of course, going to be a median voter. Right? Well, it's not kind of one in the same sense because we have a continuum of guys. But here, If I draw this in, this is the median. Right? Because half the people are to the left of that policy preference, and half the people are to the right of that policy preference. If we go back, look at our other ones. On this one here, we're looking for a place where half the people are higher, half the people are lower. Somewhere like that would be our median. Right? Half the people to the right, half the people to the left. And here with a completely normal distribution, this would be the median. Half the people to the left, half the people to the right. I'm going through and doing this because I particularly want you to pay attention to this one. There's nothing that says the median has to be in the middle, right? It's just half the people higher, half the people lower. And we have one more we might as well do. We have this one, our original weird one. And so we look for a point where half the people are higher, half the people are lower. I'm thinking it's somewhere like in here. Okay, by half the people higher, half the people lower, the lower people are this area under the curve. That's the percentage of people that have lower. And the people that are higher are the area up to the right of that curve. So we're looking for those two areas to be the same, and that gives us the median voter. Right? So there's a median voter in exactly the same way. And yeah, that's the deal. Okay, people with me on the basic assumptions of this? Okay, we've just put in lots and lots and lots of voters, right? So we don't have to worry about gaps anymore. We don't have to worry about if I change my policy that I'm offering, will I pick up any voters or not? Because there's voters everywhere. At every ideal policy, there's somebody there. So we don't need to think about these lumps of voters in the same way anymore. And this is nice for voting in a country, which is kind of what we're thinking about now, where there's loads and loads of people, and no one individual vote is super pivotal in the same way as it was when we're doing a committee of 9 people, right? So this continuum gives you that feeling, even though in real life, no country has a continuum of voters. They have a couple 100 million voters, but that's it, right? There's a limited number. Here we have literally infinite number of voters, okay? But it captures that, I think, reasonably well in an analytically tractable way. Okay. So that's our setup. And just like before, we have 2 parties, and these 2 parties are trying to decide what policies to offer these voters, right? And the voters are going to choose between the two policies. Right? Okay. Okay. So what does equilibrium look like? Well, here, our motives are a little different than they were before, right? Before it was to get 51% of the vote. Now we're trying to get as many people to vote for us as possible. We care about the percentage of voters that vote for us, not just whether we overcome some threshold. Okay, so we're looking for a Nash equilibrium. That is, we're looking for a situation where each party is doing the very best that it can, given what the other party is doing. So we're going to do it by sort of trial and error, process of elimination, the same way we did before. Yeah, and we're going to look for a contradiction. So we're going to guess that something is an equilibrium, and then we're going to show, no, somebody isn't doing as good as they could be, so that can't be an equilibrium, right? That's the basic idea, until by process of elimination, we've gotten what the equilibrium has to look like. Okay. So let's get a few possibilities here. Let's take candidate A is to one side of the median voter. What happens then? So we've picked one guy, and we said, this is what he's doing. He's moving to, say, the left of the median voter. Doesn't matter left or right. He's going to the left of the median voter. Okay? Again, the median voter seems to be critical, even though this 51% isn't a thing. But he's going to the left of the median voter. Okay? And then the other case is that candidate A is at the median voter. And there's really no other options, right? Either A is going to be to one side of the median voter, or is it going to be to at the median voter? There's nothing else left. So this is going to be totally exhaust the possible cases. Case 1, case 2. Okay. Okay. We'll start with case 1. A is on one side of the median. And I always say, well, given that that's what A is doing, what does B want to do? Okay. think about that. What does B want to do? Well, he wants to get as much of the vote as he can, so he is going to move right up to A. Right, so if we do our graph here, we have our distribution. We got the median voter, right? And I put A in here somewhere. If B goes here, well, B is going to get all of, let me actually just draw it in. If B goes here, right, B is going to get all of these voters, and they're going to split the voters up to here, right? Well, B can do better by moving in this direction. The farther in this direction he moves, the more of these in-between voters he's going to steal from A. Because the voters are going to vote for whoever's closest to them. So if this guy's doing some left-wing policy, by moving close to him, these voters in the middle don't really have a good choice, right? If B's way over here, these guys in the middle, well, some of them are going to vote for A. But the farther he moves to the left, the more of those voters he steals. Right? So B is going to move to right here, just right next to A. That way, B gets all of these voters, and A just gets these voters in here. Right? Because B is trying to get as many voters as he possibly can. It's not enough just to get 51%. He wants more and more and more and more and more. And so his best response to A going here is to move here. Okay, so that's fine. That's his best response, right? We're looking for the best response to each other, but he's going to get more than half the votes, and A is going to get less than half the votes. And so then we ask, is A happy with what he did? Right, so we started out, suppose A does this thing, moves away from the median voter. What does B do optimally? Moves close to A. Then, is A happy with his choice? And for it to be a Nash equilibrium, he has to be happy with his choice, because that's the best. We're looking for something where they each have best responses to each other. We now know if A does this, what B's best response is. But we never talked about what's best for A yet. So now we have to say what's best for A. And clearly this is not best for A. He could do better by moving just to the other side of B. Right? If B is moving here, A would prefer to be just inside of him and therefore get all of these voters. By just moving to the other side of B, he gets all the voters to the right of B instead of just all the voters to the left, and the right of B is bigger than the right of A because we are to the left of the median voter. People with me? Okay. 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 And so this can't be part of a Nash equilibrium. So our initial thing was conjecture that A goes someplace besides the median voter, to one side of the median voter. B comes next to him. A is not happy with where he went. Not a Nash equilibrium. I know some of you have had game theory, and this is like, oh, yeah. And others of you haven't, and this is kind of a new way to thinking, so I'm a little bit belaboring the point. All right. So that case one can't be part of a Nash equilibrium. That's not a Nash equilibrium because they're not best responses to each other. So our other option is for A to be at the median voter. Right? That's the only two possibilities. So then we have to think, what is the best thing for B to do? Well, if he moves away from the median voter, if he does something other than the median voter, he's going to get less than half the votes. Right? If we somehow unable to change colors, which is weird. Let's say here's the distribution of voters, here's the median, here's A. If we put B away from the median voter, then all of these guys vote for A, these guys vote for B, and we sort of split the votes between them. right? So somewhere in between them, there's a guy who is indifferent, and B gets these votes, and A gets these votes here, right? But this bit here is less than 50%, right? Because 50% would be all the way to the median voter. That's how we defined the median voter. That whole area from A off to the right to the whole end, that's 50% of the voters. So this blue area is definitely less than 50% of the voters. Okay. On the other hand, if he goes all the way to the median voter, then they're both offering exactly the same policy, and they split the votes. Everyone flips a coin. They're both, Tweedledee and Tweedledum. They're both exactly the same. Let's flip a coin, decide who to vote for. Everyone votes randomly, or however they want. But 50% of the votes will, each side will get 50% of the vote. The winner will be decided by coin toss. So by moving, same thing, by moving to the left, by moving towards the median voter, B is going to get more and more of this vote share. This indifferent guy will move farther to the left as B moves to the left, and we're going to capture all of this area here by moving there. Okay. So that's B's best response. If A is going to the median voter, then B will go to the median voter. Okay. And then, of course, it's the same thing, because B is going to the median voter, so what's the best response to A? This same logic says he has to go to the median voter as well. And so they both go to the median voter. And that is a Nash equilibrium. And that, in fact, is the only Nash equilibrium of this game. Okay. Games can have more than one. This one doesn't. This is the only Nash equilibrium. Okay. Which is exactly the same as what we got before, when we had discrete guys and it was first past the post. So actually, the model is giving us exactly the same story. That is, there's this incentive to move towards the middle. By moving towards the middle, you're stealing votes from the other guy. Whoever is most extreme is going to lose, and you can always, like by moving towards the other guy, you can steal some of his votes, and if you steal too many votes, he'll flip on the other side, so you're always competing towards the middle, and everyone offers exactly the same policy. Okay. So it turns out that this result didn't hinge on first past the post. Right? It was really about these two parties competing for votes. All right. So a couple things to say about this. This gives a reason for political parties and candidates to go towards the middle. And we intuitively know that, right? That you want to get as many votes as possible, and so you want to have a very bland policy, and you'll get more and more votes that way, right? And that does seem to capture something real, particularly if we look at the US. We see that they're very often splitting the votes, which suggests that they're doing something that, that's appealing to some kind of median voter in some sense. It may not be on policy space. It might be on the beauty of their hair. I don't know. But clearly they're doing something that's trying to split the votes. Okay, that ends up splitting the votes. So it captures something real about everyone being sort of driven towards the middle. Now, it is not true that politicians always go right towards the middle. What do we have on the next slide? We've got nothing. Yeah, that's right. It's not true that they always go towards the middle. This is giving one incentive. It's a very simple model. The world is obviously much more complicated than this little model, but the model predicts that they go towards the middle. And so let me just sort of draw that out. We got our guys. We'll put them uniformly distributed. Why not? And so our model predicts that both A and B are here at the median voter. By going towards the median voter, you can get more votes, right? That's the whole idea. Now, in real life, it's not necessarily this way, right? These two politicians are exactly identical. They offer exactly identical policies. We don't actually see that, right? We do see that they somehow tend to split the votes very often, but they're typically not identical. Right? There's some difference between them. And so we need to think sort of what incentives are there to move away from the middle. Right? Now, in economics, we have a version of this I'll come back to the incentives to move away from the middle. And that's called the linear city model. We're moving to economics here for a minute. Okay. And this is a model about product differentiation. So it's going to be exactly the same model, but we're going to have a very different interpretation, an economics interpretation instead of a political science interpretation. So our economics interpretation is that this policy that we had before, this thing that's from 0 to 1, isn't a policy. It's some feature of the product. So this is about product differentiation. Should we have the same product? Should our two companies offer different products? Okay, it's not about voting. It's about what kind of product we have. So we might have this be the shininess of the product. Should we have a very matte product, 0? Or should we have a very, very shiny product, 1? Okay. This is called horizontal differentiation. It's horizontal because, look, it's horizontal. But it's because horizontal differentiation means that it's a matter of taste. Right? All these guys have their ideal policy. Every consumer has an ideal level of shininess that they want out of this product. Some people want to be just blinded by the glare. Other people want it to be stealth so they can take it on their tactical retreats. And other people sort of in between, right? So this is the kind of thing that is a matter of taste. Products are different in a way that's a matter of taste. Right? Some people might be the size of the product. Some people want something very small that's easy to carry around. Some people want a phone with a big screen so it's easy to browse, right? And it's a matter of taste, whether you want a big phone or a small phone, right? It's horizontal differentiation. Vertical differentiation is something where everybody agrees what's better. So the quality of the product, we would like the product to last. Everyone agrees that more durable is a better thing, less durable is a bad thing. But the size of the phone, the shininess of the product, is something that reasonable people disagree about, and so that's horizontal differentiation. So this is a model of horizontal differentiation. And the metaphor they use is that we have this linear city. And it's a goofy metaphor, and I hesitate to tell you about it because it makes the model too boring. But you're going to hear about it this way, and so you should know the metaphor as economists. The story here is that we have this city. It's an old West kind of thing, right? We got this city which is on a line. The city begins at 0 and it ends at 1. And now, it's one of those one-horse towns, and Clint Eastwood's going to come walking through, and that kind of thing where there's just one road down the thing, and there's these houses along the side, and there's nothing else for miles. Or there's a railroad track going through, and everyone's along the railroad track. It's a linear city. It's a city that's built just along this line. Okay? And each person lives at a different spot. Right, so they have a different ideal spot. And so we got one guy who's living way down here on the city, one guy who's living over here, another guy who's living over here, another guy who's living over here. Right? You've seen this before, right? This is the same thing. And these guys have transport cost. That is, there's going to be some shops. Let's put a shop in here. Let's put a shop A. So that's a particular shop. We'll call it a bar because it's the Old West. And someone sets up the saloon down there at A. That's a saloon. Okay? And then everybody likes drinking at the saloon, getting shot at. That's the hobby in this town. And so, but if you don't necessarily live right at the saloon, so this poor guy over here, in order to go to the saloon, he has to walk. He has to transport his butt all the way over to A. And then at the end of the night, he has to transport himself all the way back. So going to Saloon A means he has to do that transportation. He has to move physically along that line. And of course, this guy has to go all the way over here So he has a longer distance to travel, and that poses a cost to him, a transport cost. Okay? That's the metaphor. And then it's very, very natural that if there was a saloon, say, here, that this guy would actually prefer to go to saloon B so he doesn't have to walk as far. He's more likely to get home after he's drunk. Right? That's the idea. And so this gives a reason for them to have these utility functions. It's just a saloon. Saloon's a saloon. It's all the same. But the farther I have to go to it, the less I like it, the higher transport costs I have to pay. Okay? So that's sort of the metaphor. The trouble with this is it's a nice, clean, neat metaphor. It works well. And all the jargon is sort of built around it. But it makes you think that this is a model of a city and it's about where to locate your saloon, which is fine. It is that. But it is much more about how big should I make my phone, right? It's everybody, so we want to think about this abstractly, everybody has an ideal size of phone that they want, right? They got the size of pockets they've got, they have how much they scroll versus how much they just carry it around. Some people want a small phone, some people want a big phone, some people want a medium-sized phone. And if they have to deal with a phone that's the wrong size, that's annoying for them. They got this giant phone, they can't get it in their pockets. They have this tiny phone, they can barely see the screen, right? And they have to deal with that, and that's the transport cost, right? So we could think about this as phone size, and this guy wants a giant phone. On the market, there's only a tiny phone and a medium-sized phone. He's got to deal with the medium-sized phone. And he pays a cost to do that, but it's not as big as the cost of dealing with the tiny phone because his eyesight is bad, right? Whereas this guy over here, well, she's got tiny, tiny pockets, actually no pockets whatsoever, and her eyesight is great, so she doesn't mind the small phone. Sadly, they don't make phones that small. The smallest phone they got is A. So that's the story there. So we really want to think about it as product differentiation rather than actually a physical place, even though all the metaphor is about a physical place. Okay. And then we've created exactly the same model we had before. There's nothing different about this. We got everyone distributed on the line. We got some kind of median. And by the same argument we used in the political science case, we have both of these guys going to the median consumer. There's an incentive to offer the same product as the other guy because if we got this situation up here, then guy B could move to the left and steal some of A's customers. And by moving to the left, by making a smaller phone, he can capture all these customers. These guys got nowhere else to go, so moving closer to guy A is better. But if he gets too close to A is going to make a bigger phone, and so they end up at the median voter, or median consumer. Okay. Exactly the same story we had for voters. There's no difference in this whatsoever. Okay. So all we get is a bunch of products that are all identical to each other. Well, in the phone thing, they've all kind of converged on giant phones. That's the thing. But except for Apple. And I think they're leaving the small phones behind. So giant phones is the wave of the future. But lots of things have variety in them, right? And so clearly this isn't capturing everything. And so what we can do in economics, but not in politics, is we can add prices to this. Right? Because so far we're just saying we're offering the product, which one do you want? But real life isn't like that. Real life is you say, well, this product isn't exactly what I want, but it's pretty close. On the other hand, it's ridiculously expensive. Maybe I'll get the cheaper one, and it won't be quite what I want, but it's cheaper, and I'll save the money, and I'll do something else with the money, right? And so in real life, we start thinking about what the price of the product is, not just exactly which product we're buying. So if we have that situation where we're comparing A and B, right, say, suppose you're this guy. I'm sorry, you're not that guy, you're this guy. And you're comparing A and B. Well, A is a product you like better. B is way the heck out there. On the other hand, maybe B is really cheap, right? And so we have to not only consider where do the firms want to locate, but what price do they want to set. Okay? And one problem with locating in the middle, if they both locate at the median consumer, then they're offering identical products. And then they're in very fierce price competition, right? Because if the other guy has even a penny less in price, everyone's going to buy from him. Right? So if he has a penny less than me, everyone's going to buy from him. If I have a penny less than him, everyone's going to buy from me. And we're going to work our prices down really quick. So the trouble with being at the median consumer in economics, in a product differentiation story, is that we end up with very fierce price competition. So that gives us an extra incentive to move away from the median consumer, right? Because if I move away from a median consumer, let's say I put my, and let's put our median here. And here's guy B goes here. And I'm thinking, if I go to him, if I go to the same place, yeah, we're splitting the population. That's great. But we're going to have this very fierce price competition. And in fact, we'll drive prices down to marginal cost because we're offering exactly the same product. Okay? And so if instead I move away, and if A locates over here, then, okay, I've kind of ceded the whole right-hand side of the market to him, which sucks. On the other hand, if I get this consumer here, this guy right here, now this guy likes my product more than he likes the other guy's product. And so now I can raise my price a little bit and he'll still buy from me. And so I can start charging prices that are higher than marginal cost. Even though I have fewer customers, I can charge more for my product, and that can increase my profit. Okay? Particularly if we're both at exactly the same place, we have marginal cost pricing, everyone gets zero profit. Whereas if I move to the right, move to the left a little bit, I can pick up this guy, and I can raise my price. Okay? So this having prices, choosing prices, gives us an extra reason to differentiate our product. In the base model, everyone had an incentive to move to the middle to offer exactly the same product because we're just trying to get as many people to like our product as possible. But now we start to care how much do they like our product. Because if they like our product more than the other guys, then we can charge a higher price. Okay? We're not in such fierce price competition. So this is in economics and product differentiation, we have this incentive. There's an incentive to move to the middle. That's true. That's still there. But there's also an incentive to differentiate your product in order to be able to charge higher prices. Okay? Okay. And then it depends on how we specify these transport costs. That if it's really expensive, like if it costs this guy a whole lot to instead of getting getting B instead of A is really bad. Like he really dislikes that a lot. So it's very, very expensive transport costs. Then moving a little bit away from the other guy gives us big advantage in the price competition stage because he really, really likes our product better. And so we can charge a lot more. And that's a higher incentive to move away from the other guy. Okay. Are people with me on the economic story? Okay. Okay. Well, we're not in economics. Well, political economy? I guess it's economics. But we're not. We're talking about politics. And in politics, under the laws that we live on, there's no price. You can't charge people for their votes or anything. And so this sort of incentive to move away doesn't exist. But there's actually other incentives to move away. So we're back to politics. Our 0, 1. And so we said equilibrium look like this. B, and we each get half the votes, right? We give identical policies, and we each get half the votes, was our story. Okay? And we can't charge prices, so we don't have the economics reason to move apart. But there actually is in politics lots of reasons to move apart as well. Okay? They're not in the model, but we can think about them here. Right? Why would you want to be different from the other guy? Well, first of all, if we're both offering this policy, and we're both exactly the same, then why would anyone even bother to vote in the first place? Right? It doesn't matter which guy you get. They're both exactly the same. There's no difference between them. And so there's no real incentive for anyone to get off their butt and go to the polling station. Right? Maybe have it. Maybe their grandmother makes them. But other than that, there's no reason to go whatsoever, because it's exactly identical policies. So maybe by moving away from the other guy, we can get our people to start caring about us, and then they actually go to the polls. Right? This wasn't in the model. We just assumed that everybody voted before. But it's not necessarily true, right? If you're very interested and you agree with the guy, or you really hate the other guy, then you're much more likely to go to the polls than if you don't. Okay? You might need to get somebody to give you money. Right? You might need money from donors, particularly in the US example, they're always needing money. In which case, if you're both exactly the same, why would they care? Whereas if you offer something that the donors like, then you have an incentive, you can get more money. You might need volunteers to go, ring on doorbells and to stuff envelopes and all the stuff that you need, and to watch the polls and all this stuff. If you're exactly the same as the other guy, why would anyone care enough to watch the polls? Right? Because it doesn't matter. Like, okay, you got cheated out of the election, but you're exactly the same as the other guy, so who really cares? Right? So by differentiating yourself, you can have volunteers actually start to care about whether you get elected or not, and then you can attract those guys. Right? So in politics, there is a reason why we would want to move to either side, to try to differentiate ourselves from the other guy, to get poll workers, to get donations, to get people even to care to go to the voting place in the first place. Okay. None of this is in the simple model that I gave you. This model just captures this incentive to move to the center, which is always there. But there are also other incentives. And there's versions of this model where they put those other incentives in, and it does make people move away. And the stronger those other incentives are, of course, the farther you move away from the center. Okay. Right. How are we doing? 5 minutes. Now, I feel like I should talk longer about that because that's actually important, that this model is just capturing one incentive. It's not capturing everything. And in particular, in politics, people caring about you matters a lot. And so there's this incentive to move away from the center. It's not like super deep, and it's not hard to get, but I would say it is important, and I also want to make sure that you sort of circle that somewhere in your notes. Okay. Now, we started out motivating this whole thing by saying, okay, we want to do proportional voting because it's all well and good to model the US, and I'm sure that's lovely for them, but it's a very small part of the world, and it's not the part of the world that we live in, and so maybe it would be nice to understand our local politics, local, you mean all the rest of the world except for the US, by doing a proportional voting system, right? That was my motivation. And we say, okay, we get the same thing, everything is great. Except, and this is important, we only have two parties, and that made perfect sense when we were talking about the US, because the US basically only has two parties that matter, right? So we could talk about A and B, and that was fine. But if we start to talk about any place in Europe or most of the rest of the world, there are more than two parties that matter. So we should really be talking at least about A, B, and C, deciding where to go, right? A and B isn't enough. So we really need to be thinking about more than two parties and see what this model has to say. Okay. And you will notice when I talked about, this model is so powerful, it really captures something real, I keep talking about the US splitting the vote. I never talked about Germany splitting the vote or Ireland splitting the vote. And there's a reason for that, because the model is going to show us that we won't. That if we have more than two parties, that everyone goes to the middle thing breaks down. Okay, so we want to see that. So we've got A, B, and C. Now I know there's more than three parties, and things get very complicated and all that, but three is enough. If we have three, we can see what's going on. So A, B, and C, those will be our parties, and they're deciding where to locate. Okay. Now some things are easy, like most extreme guy. The most extreme guy on either side will want to move to a less extreme position. Right, so if I draw this out, and we've got A, B, C, then guy A would definitely prefer to move closer to B. Right? Because if he moves closer to B, he starts getting, before they were splitting the votes, as he moves closer to B, he starts stealing these voters from B. Right? So in any equilibrium, there can't be any gap between the guy on the left and the next guy, because you always have an incentive to move towards the middle. Same thing on the right. Guy C would prefer to move closer to B. Right? So then you say, well, okay, those guys want to move close to B. Maybe everyone snuggles up real nice and close, and it's sweet. Right? Maybe that's what goes on. And so let's do it again. And we're going to have B here, A snuggled up real close, C snuggled up real close on the right. And there you go. Everyone kind of went to the middle. A gets all of these votes. C gets all of these votes. And B gets no votes really at all. So B's not going to be happy with this, and he's going to move to one side. So that can't be a Nash equilibrium either. Right? Because B is not going to be happy with his choice there. And lastly, maybe they're all in exactly the same spot. Maybe that's even the median voter, but we don't even need that. I'll put A, B, C there. Right? And so here, they're splitting the vote. And just like we had before. And that's sort of our natural inclination. Before, with two parties, everyone went to the median voter, and they split the vote. So maybe they're doing the same thing with three parties. Except here, they're all getting 1/3 of the vote, whereas if we move to the larger side, goes from 1/3 of the voters to at least 1/2. Right? If they're at the median voter at the moment, if he moves a little bit, he'll get all of this side, which is half the voters. So when he's at our supposed equilibrium at the median voter, he gets 1/3 of the voters. If he moves just a little to one side, he gets half the voters. So he's not going to be happy with this, right? And if they were away from the median voter and they were all in the same place, then he would get even more, because that side would be even more than half the voters. Okay? So he's not going to be happy with this either. So if we have three parties, there is, in fact, no Nash equilibrium. Now, those of you who took game theory know that what I mean is there is no pure strategy Nash equilibrium. There is, of course, equilibrium in mixed strategies, which, can I have time to explain that to you? No, I can't. I'll let you go. We'll talk very briefly about that next time.